So today we're doing 3-3 systems of inequalities. Our learning objective is to solve systems of linear inequalities. We were before using graphing, substitution, and elimination to solve systems of equalities. Now we're going to apply that to equations that have less than, greater than, less than or equal to, greater than or equal to. So same rules kind of apply. Now we just get more shading. This just gets a shadier version. So please write this down. An inequality and a system of inequalities can each have many solutions. A solution of a system of inequalities is a solution for each inequality in the system. Start that sentence, those two sentences down. Okay, so essentially we can solve a system of inequalities in more than one way. Graphing the solution is usually the most appropriate method. The solution is the set of all points that are solutions of each inequality in the system. So if it satisfies both, then it is a solution. So we're going to solve this system by graphing, and I am going to employ the help of my friend slope-intercept form. I find it so much easier to graph when I'm in slope-intercept form that I will do the algebra required to convert in order to graph in an easier manner. All right, so if I have a nice little graph here, so if you guys don't have graph paper, you can go ahead and get a piece, because we are going to be solving the system by graphing. So I'm going to, let's go ahead and graph y greater than or equal to negative 1/2 x plus 1. So I can see, comparing it to my slope-intercept equation, that my intercept is at positive 1. So if I have my axes marked, positive 1 on the y-axis is right here. I can check out my slope. It is negative 1 over 2, so I'm going to go down 1 over 2. And continue that across the graph. I'm going to get my straight edge. Some of you guys, sad panda, tried to graph in your portfolio and did not use a straight edge, so you missed points for graphing without a straight edge. If you are producing a line, make sure it is a true line produced by a ruler as straight as possible. I can make this a solid line because I've got an equals to sign, greater than or equal to. All right, so we want to graph all of my y values that are above or greater than the line negative 1/2 x plus 1. So I'm going to go ahead and shade everything above that line. All right, so for my next inequality, we got 2x minus y greater than or equal to negative 3. I am going to add y to both sides. And add 3 to both sides. I'm going to flipsy-flopsy this and go y. As long, my alligator is not eating the y, he's eating the 2x plus 3. That way I've got my slope is 2 over 1. And my intercept is 3. So on my graph, I find 3 is my y-intercept, and I go up 2 over 1. And then I repeat that same pattern. across. And then we got a shade, shade, shade. So I'm going to shade all my y's that are less than or equal to that line. Actually, let me put in my line. Yeah. So using your straight edge, that line, I can make a solid line because it is equal to. Now I'm going to shade. Green, I want everything below that line. So I'm going to put my finger on the line and then everything down below. All right, then I want to go a little bit darker in my double shaded region so that you can see. So this here, where we're double shaded, is the solution. What else are you guys doing? We're just sitting here doing math together, so we might as well practice this. So we have x plus 2y less than or equal to 4, and y greater than or equal to negative x minus 1. And for this guy, I'm going to subtract x from both sides. And then I'm going to divide everything by 2. I get y less than or equal to negative 1/2 x plus 2. If you are missing any, if this part is at all confusing to you, put a star next to it, highlight it, and let me know as soon as we're done with these notes so that I can help you understand how we got y less than or equal to negative 1/2 x plus 2 from our original function. All right, so we're going to put that on our graph. Here's our x and y axis. So we're going to start at positive 2. And we're going to go down 1 over 2. We draw a nice straight line using our ruler or straight edge. And I can make it solid because I am equal to. And then I want all my y values that are below or less than this line. So we are going to shade everything underneath this line. All right, so for our next line, we are going to I'm just going to rewrite it a smidge so that I can clearly see that my slope is negative 1 over 1. So my coordinate starts here at negative 1, and I go down 1 over 1. And I continue that pattern all the way across my graph. I get a line and draw a straight line across my graph. And then I want all of my y's above or bigger than my line negative x minus 1. So I'm going to shade everything above that line. So everything above and then my double shaded region, which right here is in blue. Is my solution to the system of inequalities. So you need the graph to represent your solution because there's so many in the overlapping region. Okay, one more practice. Assume that x and y are whole numbers. What is the solution of the system of inequalities? And just for fun, I'll show you how to use intercepts to graph, just for fun. So I'm going to put my x and y axes on here. So I'm a y equals mx plus b kind of girl, but I'm not going to downplay. I'll go along with anything. Okay, so for our inequalities, to graph the x and y intercepts, I'm going to go ahead and treat them like equations of lines. So in x plus y equals 4, and 3x plus 7y equals 21. So my x-intercept, that's when x is equal to 0, and then we're finding the y value. So I'm going to put 0 in for x here. So if x is equal to 0, y is equal to 4. So I know my x-intercept is at 0, 4. Let's go ahead and put that on our x-intercept, 0. That's a y-intercept. It's going to be easier to change this than to erase. All right, so my y-intercept is when x is equal to 0, and my x-intercept is when y is equal to 0. Okay, so my first function, x plus y equals 4. When I plug in 0 for x, I get out 4 for y. So I plot the point 0, 4. To get my x-intercept, I plug in 0 for y. I get x is equal to 4. And so my x-intercept is at 4, 0. I have 2 points on my line. I get my straight line maker. And then I have to kind of shuffle. Then I kind of shimmy this line where it needs to be. Perfect. And I actually have to make a dashed line because we are greater than, x plus y greater than 4, so we're not equal to. Okay, so it's dashed. The only problem is I need to know, do I shade above or below? And my test of whether I shade above or below is what y is bigger than or is y less than. So at the end of the day, I'm going to end up solving for y anyway. So I want y bigger than my nice little green line here. So I'm going to shade above. I accidentally touched the line, and I'm not allowed to. All right, for my next line, we'll use the intercept method, even though I am gonna eventually just solve it back out. So if I plug in 0 for x, I get 3 times 0 plus 7y equals 21. That's also equal to 7y equals 21. Divide both sides by 7. Y equals 3 is my intercept. So I'm going to use this. So when x equals 0, y is equal to 3. Right there. Then I'm going to put my 0 in for y. So I get 3x plus 7 times 0 equals 21. Or 3x equals 21. Or I'm going to divide by 3, and I get x equals 7. So when y equals 0, x is equal to 7. And I grab my straight line. I am solid this time. Oh, yeah, I got that. I wanted to do this. There we go. Make it nice and straight. For my really super mathy people, put the infinity line on the end of it. Now I need to know whether I shade up or I shade below. So I'm going to go ahead, if I subtracted 3x from both sides, divide by 7, I can see that it's y less than, so I'm going to shade below. Y is on the left-hand side of the less than, so we shade below. And let's get yellow. So we shade below, and our double shaded region is right, this little sliver right here. And that is the solution. Since you guys are going to be expected to do a word problem for your portfolio, and in fact, for every section that you do a portfolio problem for, it's going to be a word problem. I'm going to show you how a word problem can be graphing inequalities. Pizza party charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each type of topping can you get on your pizza? So we're going to let B be the veggies and be the meat. Let's look at the second sentence. You want at least 5 toppings on your pizza. So you want veggies and meat to be greater than or equal to 5. You want your veggies and meats to be at least 5 toppings. If we can afford more, then we'll put more on. The next one, we have $10 to spend on toppings. Anytime you're looking at money, you go, I'm going to take my cost, multiply it by how many I have, plus the cost for my other item, multiply it by how many I have. So how much is a veggie cost? $1. So I'm going to go $1 times V. So however many veggie toppings I get, I'm going to spend $1 per topping. then it's going to be $2 for the meat toppings. So whatever, however many veggie toppings I get, times its price, plus however many meat toppings I get, times its price, is going to have to be less than equal to $10. Because I have no more than $10 to spend. Alright, so we're going to graph this. So I'm going to let my meat be on the Y and my V be on the X. Look, meat's on the Y, V's on the X. So if I solve for VM, I get M is greater than or equal to negative V plus 5. So for this problem, my intercept is at 5. And my slope is down 1 over 1. And I have a solid line because I can be equal to it. And I want all ends that are bigger than my green line. So let's get my green highlighter. For my second one, I'm again going to solve for M. Subtract V from both sides. I get negative V plus 10, and then I'm going to divide everything by 2. And I get M is less than or equal to negative 1/2 V plus 5. So that starting point is at 5, just like my other starting point, my y-intercept. Then I'm going to go down 1 over 2. There's my line. I'm going to be solid line because I can equal . And I want everything below that line. So I'm going to shade lower. So how many of each topping can you get on your pizza? So I'm going to remove a little bit of my shading so that I can actually see, because I know that this little triangle here, this black triangle, is my OK region. Those are my acceptable values. Am I going to ever get negative meat toppings? No. So I don't care what happens when M is less than 0. And I'm never going to get negative V toppings either. So I don't care when V is less than 0. So technically, I only care about this graph from 0 to, let's see, 5, 6, 7, 8, 9. 0 to 9? Or is it 0 to 10? Down, so down 1 over 2, so 10. So if you look, every whole number that is in our region is a possible solution. So I could have 3 veggie, 3 meat. I could have 4 veggie, 2 meat. If it's not a whole topping, it really isn't an answer to this because I can't order half a veggie topping. Just cut that. bell pepper in half. Throw it on there. You got to go one whole. So then I can also have 1, 2, 3, 4, 5 veggie and 2 meat. I could have 2, 3, 4, 6 veggie and no meat. I could have 6 veggie and 1 meat. So each of these, you may have to list all of your possible solutions. Just be prepped in case it comes up. It's just all the corners of your boxes within your graph you have to list them. Okay, I have one more. This is it. This is the end. One more. And this one is a doozy. This one needs a graph, so I'm going to go back and get. Alright, I'm going to rapid fire graph these 2 functions. And if you need help graphing or knowing how to graph these, please make a note, circle, highlight, whatever, and then come see me later. And I would be happy to explain how to graph these. But since that's a topic for that we've already covered, I'm not going to spend a significant amount of time on it. So I'm going to graph this first line. He is going to be definitely dashed because I cannot equal him. So he starts at 1, and he goes down 1 over 3. And I want to shade everything below him. And then my other guy is an absolute value. He's normally a V-shaped. So not only is this guy a V-shaped, but he was an upward-facing V-shape since we have a positive value in front of the absolute value. And he's also shifted to the right 1 and has a vertical stretch of 2. So he is going to be, it's going to look like, and I can also, in this case, I cannot equal him, so he has to be dashed. So we're going to shift it to the right 1. So the vertex is going to be at 1, 0. And then he has a vertical stretch of 2. So instead of having a slope of over 1 up 1, he's going to have a slope of over 1 up 2. And since he is symmetrical, it's the same on the way back. So nice little absolute value function. He is going to be dashed. So everywhere I put a little dot, I'm just going to put a dash mark. And I want to shade all my y values greater than the absolute value. So that is everything inside of the V. So technically, my little overlapping region is right here. It's right by the vertex of the absolute value. Just in that little tiny region do we have the solution to these 2, where it's less than my line and greater than my absolute value function. Okay, take a moment, write your summary. Please remember our learning objectives. We're solving systems of linear inequalities.